Hi everybody, good afternoon. We are on the Kansas River today. It is June, and June means of course that the sun is highest in the sky on the northern hemisphere, and it's in fact close to the 23.5 degrees north of the equator that it gets to in the height of summer. We are ourselves at 39 north, as you know, and so 15.5 degrees off vertical is where the sun is right now, and it does feel like that. It's very, very high above us. It's a hot day. We find ourselves here on an island in the middle of the Kansas River. You probably know that we have many of these sandbars or tiny islands, and it's a good place to talk about discharge. Discharge, you remember the formula, Q for discharge equals width times depth times velocity, and for width maybe we should take 200 feet or so, let's say 60 meters. For depth, we've been touching the ground on occasion, and of course the depth isn't equal everywhere, but let's say that the depth is about 2 meters here. So 2 meters times 60 meters is 120 square meters, and if we take for speed, maybe let's look at the water over there. And you see it floating quite quickly past the shoreline there. Maybe we pick a 1 meter per second speed. Then we would end up at 120 cubic meters per second of discharge, and that would be also the right unit, right? Volume per time, cubic meters per second. So let's just walk a little bit further, look at some of the rocks that we're finding here on this island. It's pretty cool. So maybe the first thing we can look at over here is a funny natural phenomenon that we call imbrication. Imbrication is the term for when you find pieces of gravel like this, generally stacked in this direction, that my hands are now trying to indicate. And you can see that is not true for every single rock, but it's true for many of them. For instance, over here, this one is stacked in that direction. This one is stacked in that direction. This one too, and that's that's, if you keep on looking over here is another little batch that is stacked in this direction. It is leaning in the downstream direction, and that has to do, of course, with the process of deposition. Imagine you were a rock, and let me pick one. Let me pick this one, and imagine you were deposited like this for a second. What would happen, of course, is you would be catching the water very well, and the water will be able to push you over until you're supported by the next one, and that results in this pattern that we see. So imbrication tells you about the direction of flow. Now in this case we know the direction of flow, that's upstream, so of course it's expected that imbrication develops in this way. But in some other cases where we find really old deposits where the river is no longer in sight, and we don't maybe even know which river it was in the very long past, then imbrication can tell us about the flow direction at least. So that's very, very cool. Another thing that we could really briefly talk about here, and that you can really see nicely on these sandbars, is the kind of rocks that make it onto the sandbars. We would expect to see the rocks that are present in the upstream catchment. And so what is present in the upstream catchment for the Kansas River is a lot of limestone. We know about the flint in the limestone. We know about shale. If you look around you, you see a lot of limestone, and you see this is, for instance, limestone. This is not limestone, this is flint. Here's another piece of flint, another piece of flint, another piece of flint. What I'm trying to get at here with you is that we find a lot more flint here than we find in the bedrock of our landscapes around us. And that has to do with the fact that flint is much better preserved. As you know, flint doesn't like to erode, doesn't like to weather. And so flint persists much better than limestone does. Limestone, as you know, dissolves quite well. And therefore we see this relative exaggeration of the amount of flint in the river deposits relative to the landscape. If you manage to account for that, and we can of course these days account for that, then the composition of what we find in these sandbars tells you a story about what's upstream. If we again look at an older deposit where the river is no longer in sight, and we find an older deposit that contains quartzite and granite, then that old river that may no longer be there used to drain an area with quartzite and granite. And so that's a little bit of a sort of forensic physical geography, if you want, where we can learn about those past landscapes really well by looking at the deposits that were left by the rivers in them. I guess that's it. It's probably time to go back to kayaking again for us, and I'll see you next time.